In this lecture, we'll discuss rainbow tables. As we've already seen, passwords are normally stored in one-way hashes. When a password is created, the user types the password in so-called plain text or clear text form. Then the computer calculates and stores a one-way hash of the password so that no one, not even the admin, could see the clear text password. For example, this is the hash of the password of user 1. Hashes are made to be one-way, which means they cannot be reversed, or in simple words, if you have the hash, you cannot find out from what password was the hash generated. A hacker has to crack those hashes. Normally, when someone cracks a password hash, he generates the hash from a word, then compares it to see if there is a match. If there is, the word is the password. If not, the hacker will repeat this operation. This proves to be really time-consuming. It can take days, weeks, or even years if we are dealing with a strong password. Rainbow tables, on the other hand, are based on the principle of a time-memory trade-off. This means that hashes are pre-generated by a computer and stored in a large rainbow table file with all of the hashes and words that correspond to them. A rainbow table can be thought of like a dictionary. It holds combinations of characters on one side and their hashed form on the other. Rainbow table cracking can greatly reduce the amount of time it takes to crack a password hash, plus you can keep the tables, so you only have to generate them once. The downside of using rainbow tables is that it takes a very long time to generate them and occupies a lot of storage, but once they are generated, they can be easily used. There are a lot of rainbow tables available on the internet, both free or not. For example, you can find a lot of rainbow tables that are free to download at freerainbowtables.com. Each rainbow table is for a specific hash algorithm, and we notice how much space they require. For example, the rainbow table for all alphanumeric passwords with a length of 1 to 9 occupies 1 terabyte. The hash algorithm is MD5, which is, by the way, an old and obsolete hashing protocol. If they would use a new protocol like SHA-512, the size of the rainbow tables would be much larger. Another interesting website is crackstation.net. Crackstation uses massive precomputed lookup tables to crack password hashes. Crackstation's lookup tables were created by extracting every word from the Wikipedia databases and adding it to every password list they could find. They also applied intelligent word mangling or brute force hybrid to those word lists to make them much more effective. Only for MD5 and SHA-1 hashes, the rainbow table is 190 gigabytes. It also supports a lot of hashing algorithms, the old ones like MD5 and SHA-1, but also new ones like SHA-256 and SHA-512. Let's see how it works. I suppose that a user sets his password as being Apple and uses MD5 as the hash algorithm. Using this online tool, I'm selecting MD5 and the password, Apple. This is its hash that will be stored in a file. I'll paste the hash in crackstation.net. Another user has as password green apple. It's calculated using SHA-1 and it's stronger, having a length of 10 characters. So green apple. I'll paste the hash in CrackStation. Let's see the hash of a third password, which is măr verde, which means green apple in Romanian. I'll select another hash algorithm, SHA-256. Măr verde. I'm copying the hash and then paste it in CrackStation. And the last one, a stronger one, let's say special player, using a very strong algorithm like SHA-512. I'm selecting the hash algorithm, special player. You can see that X hash is much larger. I'm pasting it here. Let's crack them. I'm not a robot. And crack hashes. Wow! We notice that all passwords have been cracked. The hash, the algorithm, and the password. Their hashes were already in the rainbow tables of crackstation.net, and the application only searched for those hashes, which was a simple operation. Now, if a user takes security seriously and sets a strong password, it won't be cracked so easily. Let's try a password with a length of at least 10 characters, both lower and uppercase letters, digits, and special characters. This is a strong password. It has a length of 10 characters. Let's try to crack it. It couldn't be cracked. Okay, that's all about rainbow tables for the moment. In the next lectures, I'll show you how to generate your own rainbow tables and how to try to crack hashes using the generated tables.